sump pump is a pump used to remove water that is accumulated in a water collecting sump basin, commonly found in the basement of homes. The water may enter via the perimeter drains of a basement waterproofing system, funneling into the basin, or because of rain or natural groundwater, if the basement is below the water table level. Sump pumps are used where basement flooding happens regularly and to solve dampness where the water table is above the foundation of a home. Sump pumps send water away from a house to any place where it is no longer problematic, such as a municipal storm drain or a dry well. Pumps may discharge to the sanitary sewer in older installations. Once considered acceptable, this practice may now violate the plumbing code or municipal bylaws, because it can overwhelm the municipal sewage treatment system. Municipalities urge homeowners to disconnect and reroute sump pump discharge away from sanitary sewers. Fines may be imposed for non-compliance. Many homeowners have inherited their sump pump configurations and do not realize that the pump discharges to the sewer. If the discharge is fed to a laundry sink in the basement, it's likely going to the sewer. Usually hardwired into a home's electrical system, sump pumps may have a battery backup. The home's pressurized water supply powers sump pumps, eliminating the need for electricity at the expense of using potable water, potentially making them more expensive to operate than electrical pumps and creating an additional water disposal problem. Since a sump basin may overflow if not constantly pumped, a backup system is important for cases when the main power is out for prolonged periods of time, as during a severe storm. There are generally two types of sump pumps: a pedestal and submersible. The pedestal pump's motor is mounted above the sump, where it is more easily serviced, but is also more conspicuous. The pump impeller is driven by a long, vertical extension shaft and the impeller is in a scroll housing in the base of the pump. The submersible pump is entirely mounted inside the sump, and is specially sealed to prevent electrical short circuits. There is great debate about which variety of sump pump is better. Pedestal sump pumps usually last longer if they are installed properly and kept free of debris. They are less expensive and easier to remove. Submersible pumps will only last 5 to 15 years. They are more expensive to purchase but can take up debris without clogging. Sump pump systems are also utilized in industrial and commercial applications to control water table-related problems in surface soil. An artesian aquifer or periodic high water table situation can cause the ground to become unstable due to water saturation. As long as the pump functions, the surface soil will remain stable. These sumps are typically 10 feet in depth or more, lined with corrugated metal pipe that contains perforations or drain holes throughout. They may include electronic control systems with visual and audible alarms and are usually covered to prevent debris and animals from falling in. Components: modern sump pump components in the United States are standardized. They consist of a plastic, metal, or concrete container forming a sump basin, approximately 2 feet across and 2 to 3 feet deep. 15 to 25 U.S. gallons capacity. A sump pump either 1/3 or 1/2 horsepower, either battery or mains powered. Pump selection: the selection of a sump pump will rest heavily on the application in which it will be used. To select the appropriate sump pump, consider the following: automatic versus manual operation. A selection of a manual sump pump means that one will turn the pump on and off when appropriate. Selecting an automatic sump pump means that a switch is wired to the sump pump to turn it on or off at appropriate water levels. Automatic switches include pressure switches, low-level pressure switches, float switches, and a solid-state water sensor called field effect. Power: a sump pump motive power will vary from 1/4 horsepower to multiple horsepower. Head pressure: the head pressure of a sump pump describes the maximum height that the pump will move water. For instance, a sump pump with a 15 feet maximum head will raise water up 15 feet before it completely loses flow. Technically, head pressure is defined as an expression of a pressure in terms of the height of fluid. P equals Eg, where Y is the fluid column height, I is fluid density and G is the acceleration of gravity. Other considerations may be added to overall head pressure, including loss from elbows bends and friction loss from long horizontal runs. Power cord length or it is important to consider the length of the cord of any special switches that may be connected to the pump. Running a more powerful electrical motor a long distance from the main service panel will require heavier gauge wiring to assure sufficient voltage at the motor for proper pump performance. Phase and voltage Sump pumps powered from the AC mains are available with single-phase 3-phase motors, rated for 110 to 120, 220 to 240, or 460 volts. 3-phase power is typically not available in residential locations. Water level sensing switch type pressure switches are fully enclosed, usually inside of the pump body, making them immune to obstructions or floating debris in the sump basin. Float switches, particularly the types attached to the end of a short length of flexible electrical cable, can get tangled or obstructed, especially if the pump is prone to movement in the basin due to torque effects when starting and stopping. Pressure switches are typically factory set and not adjustable, while float switches can be adjusted in place to set the high and low water levels in the sump basin. There is a solid-state switch utilizing field effect technology which will turn on and off the pump through use of an internal switch and a piggyback plug. Backup system and alarm if redundancy and an alert system are vital for operation of your sump pump, consider a backup system and/or alarm. Backup components. A secondary, typically battery-powered sump pump can operate if the first pump fails. A battery-powered secondary pump requires the following components in parallel with the above others: a battery-driven 12-volt sump pump with its own water level sensor, piping, and check valve. It must be a marine deep-cycle battery, or special long-life standby battery. Standard automobile batteries are not suitable for this application. Auto batteries are designed to deliver a high current for a short period. Some pumps need a smaller current for a long time. A trickle-charge battery charger may alternately have a specialized controller to manage, monitor and test that the battery holding a charge. Alternative sump pump systems can be driven by municipal water pressure. Water-powered sump pumps are similar to backup battery-driven systems with a separate pump, float and check valves. One can also use an ejector pump that uses an ordinary garden hose to supply high-pressure water and another garden hose to carry the water away. Although such ejector pumps waste water and are relatively inefficient, they have the advantage of having no moving parts and offer the utmost in reliability. If the backup sump system is rarely used, a component failure may not be noticed, and the system may fail when needed. Some battery control units test the system periodically and alert on failed electrical components. A simple, battery-powered water alarm can be hung a short distance below the top of the sump to sound an alarm should the water level rise too high. Maintenance: sump basins and sump pumps must be maintained. Typical recommendations suggest examining equipment every year. Pumps running frequently due to higher water table, water drainage, or weather conditions should be examined more frequently. Sump pumps, being mechanical devices, will fail eventually, which could lead to a flooded basement and costly repairs. Redundancy in the system can help to avoid problems when maintenance and repairs are needed on the primary system. When examining a sump pump and cleaning it, dirt, gravel, sand, and other debris should be removed to increase efficiency and extend the life of the pump. These obstructions can also decrease the pump's ability to drain the sump, and can allow the sump to overflow. The check valve can also jam from the debris. Examine the discharge line opening, when applicable, to ensure there are no obstructions in the line. Even a partially obstructed discharge line can force a sump pump to work harder and increase its chance of overheating and failure. Float switches are used to automatically turn the sump pump on when filled to a preset level. Float switches must be clear of any obstructions within the tank. A float guard can be used to prevent the float switch from accidentally resting on the pump housing, and remaining on. See also, Sump, footnotes. Resources: Ann Cameron Siegel, The Sump Pump's Fault, or Yours. Washington Post, August 9, 2008, Sump Pump Helps Keep Water Out, North Dakota State University Extension Service, June 14, 2005, Thomas Scherer, Sump Pump Questions, North Dakota State University Extension Service, sizing up a sump pump, University of Illinois Extension, John Newton and Company. Sump pumps, your questions answered.